Welcome back to the Aluminum Channel. I'm Scott Drake. My guest is Doug Richmond. He is the Vice President of Engineering and Technology at Kaiser Aluminum as we continue our discussion on aluminum in the automotive industry. Doug, what is the role aluminum is playing in achieving the 2025 CAFÉ standards?
Well, Scott, it's really great to see you again, and I appreciate you asking us about this very important question. But before I jump into the technical discussion of aluminum and the CAFÉ regulation, I'd like to make sure everybody understands how really valuable the combined efforts of EPA, NHTSA, and the California Air Resources Board have been in drafting this far-reaching and far-sighted standard. In the past, CAFÉ regulations have been drafted for about a 5-year time frame. And that left car company planners and car company engineers and manufacturing investments at risk and uncertain about the requirements out in the future. And in most cases, the planning cycle for most of these programs is substantially longer than 5 years. By drafting a standard and a recommendation out to 2025, the risk of advancing technological fronts in every aspect of the car have been reduced dramatically, and the engineers are responding with creativity, and the car companies responding with great investments. And we're seeing the technology leaping forward in a terrific way. The other significant advantage here is the combined efforts of the California Air Resources Board with EPA and NHTSA to come up with a 50-state standard, one set of technology that meets all consumer needs and regulatory requirements in North America. That's a terrific advantage for the auto industry in North America and helps move the technologies required forward at the maximum pace possible. The CAFÉ requirements for 2025 require all manufacturers to meet a corporate average fuel economy of 54.5 miles per gallon. That's a significant increase from the current corporate average fuel economy in North America of approximately 30 miles per gallon. About 24.5 miles per gallon of improvement will be required from 2012 to 2025. Now, mass reduction is one of the strategies that will be deployed to meet those requirements. But there's a whole portfolio of other technologies, including terrific advancements in engine control technology and engine combustion efficiency, transmission efficiency, multi-speed transmissions, aerodynamic improvements, and friction reductions. All of these technologies, combined with weight reduction, will be required to meet the 54.5 requirement by 2025. Aluminum has a very important role to play in achieving that objective.
Doug, why aluminum as opposed to composites or high-strength steels?
Aluminum has a very unique and valuable collection of properties that they offer the automotive engineer. The first and foremost is, of course, a very high strength-to-weight ratio. The average strength of the grades of aluminum used in the auto industry is approximately the same strength as mild steel that's been traditionally used in automobiles since the car was invented. Now, but aluminum has a density or a mass that's 1/3 the mass of steel and iron. So aluminum offers a much better strength-to-weight ratio in strength-related applications in the automobile. Aluminum also has natural corrosion resistance that is valuable to the auto industry and compatible with the automotive use environment, and is formable in the broadest range of fabrication technologies that are used in the auto industry. Aluminum can be rolled, it can be forged, it is machined, and it is extruded. It is the only material that can be processed in all of the prominent manufacturing technologies used in the auto industry today. Over the years since aluminum conversions started in the auto industry, since about 1970, automotive engineers have consistently learned aluminum offers the cost-effective solution to significant weight reduction in a vehicle. Aluminum growth between 2015 and 2025 will be predominantly in vehicle body components and closure panels. During that time frame, the amount of aluminum used for auto bodies in North America and will increase from 200 million pounds in 2015 to 4 billion pounds in 2025. Now, those body components will be composed predominantly of sheet product. About 90% of the gain will be in sheet product, and about 10% of the gain will be in extruded products. Those components, body components that are body structure and closures, are evaluated in most alternative materials, including high-strength steels and composites. In that competition, engineers have learned aluminum offers the most cost-effective solution for the engineering requirements of body componentry.
All right, Doug, great. Thank you for talking with us.
Thank you, Scott. It's a pleasure talking to you about one of my favorite topics.
That's Doug Richmond. He's Vice President of Engineering and Technology with Kaiser Aluminum. I'm Scott Drake. Thanks for watching the Aluminum Channel.